Let's take for example, we have a function y raised to power 2 equals 9, and we are asked to find y. What this means is that for us to get to y, we need to remove what appears to be a constraint, a hindrance, a stumbling block from us getting to y. Because we want to get to y, we want y to stand alone. But it's y that we want it to stand alone has square. It has a power 2. So we need to remove the 2 so that y can stand alone. That's what it means by most of the times when they say find y or solve for y. We are going to remove 2 and take it to the other side. The operation here is that y is undergoing a basic operation of power. So for us to remove this power, if we say let this power 2 leave, we'll now be left with what? Y. And then the power 2 is now in the air. After y, 2 is in the air, we meet equals to. After equals to, we meet 9. And the 2 that is in the air, having crossed the equality sign, tending to land, it changes its functionality. It becomes inverted as an index, which from this illustration is the same as the square root of 9. And having known that the square root of 9 is 3, we write it as 3. So mathematics is just, it's a system. It's a system, it's a rearrangement. And once we know the move, the code of conduct for the rearrangement, we simply apply them and we find our answer. So that is for power. And the same way, if we had this and we just want to make 9 stand alone, we can ask the index of half to leave. And if it comes here, it inverts itself and becomes 2 all over 1, which is 2. Remains y raised to power 2. So that is the case with that. Another one is where we see multiplication. Let's assume we have 2 times 3 equals, say, we know it is 6. So let's take, for example, this is taken as y. So if we say we want to solve for y, how do we do that? The question is, what operation are these two undergoing? The relationship between 2 and y is multiplication. 2 is multiplying y, which oftentimes we may see written as 2y. If a number and a letter are fused together in this manner, there is multiplication between them. So their operation, the relationship between both of them is multiplication. So 2y equals 6. So by this, we may be asked to solve for y, meaning they want y to stand alone, and 2 is in its way. So the question will be, what operation, what is the relationship between y and 2? And the relationship between them is what? Multiplication. If we remove 2, we will now have y. Now the 2 is in the air. We meet equals to. The 2 is still in the air. We meet 6. Now the 2 has to come down to this other side. And for it to come down, it is going to switch its functionality, its operational sign. It was undergoing multiplication, now it turns to division. So it becomes, now that it learned, it becomes divided by 2, which we can also write as 6 divided by 2. But of course, we understand these two are the same. So at the end of the day, what we have 3. So this shows us the illustration to explain this. Let's take plus and minus, addition and subtraction. If we have 5 minus 3, we know the answer is 2. So let us now assume that we do not know this, that this is y. So the question is, solve for y. The question I will be asked, for us to get to y has a relationship with minus 3 at this left hand side. 2 stands alone by the right hand side. So for us to get to y, that is for us to solve for y, for us to evaluate y, we need to move minus 3 away from y so that y can stand alone. And then what do? We ask the question, what is the operation happening between y and minus 3? What is the functionality? And it means the functionality there is subtraction. So we say, since the relationship between the y and 3 is subtraction, let us move 3, having in mind that they have a subtracting relationship. So we tell minus 3 to leave, and we are left with y. Minus 3 is still in the air. We meet equals to, remember the bridge or the fence. And then we meet 2. And then it's now time for minus 3 to fall down from the sky. And then, alas, it's going to change its operation from being subtracted to being added. That's where subtraction changes. Having crossed the equality sign, it becomes plus, and then you have plus 3. And primarily, we know that 2 plus 3 is 5. We now conclude that y is equal to 5. So basically, if we look at these basic operations, vis-a-vis their relationship when they want to cross an equality sign, that is being in an equation, this is how they are being processed. This is the activity they go through. If one is leaving its operation, it changes to its friend in the other side. If the other is leaving, it equally changes to its friend. So that is the relationship between family A and family B. So in any way, this can be family B, this can be family A. What we want to emphasize, we just brought in the concept to be able to explain this better to you, so that you know what happens and how these mathematical operations are processed when they are used in equations. Don't forget, once again, this is Chris Study Studio. We teach mathematics, physics, and chemistry with concepts. Thank you for watching. See you next time. Bye.